This question is magnetic lines of force due to straight conductor carrying currents are magnetic lines of force due to straight conductor carrying currents are straight lines, electrical, circular, parabolic. So correct answer is circular. Correct answer is circular. Of the magnetic lines around the straight conducting wire. Okay, so this is the wire. So magnetic lines will be like this. Okay, magnetic lines will be like this. Okay. So around the circular conducting wire, magnetic lines is circular. The next questions. A magnetic field exerts no force on a stream of electrons, a stream of protons, unmagnetized piece of iron, and a stationary charge. Okay. So we're talking about question magnetic field exerts no force. Magnetic field exerts no force on a stationary charge. Okay. If the charge is stationary, it will exert no force. If the charge is stationary, it will exert no force. If the charge is stationary, it will exert no force. The charge is stationary, it will exert no force. So magnetic field exerts no force on a stationary charge. Magnetic field not exerts any force on a stationary charge. If the charge is stationary, so there will be no force. If the charge is moving, then there will be force. If the charge is moving, then there will be force. Next question, a current carrying power lines carries current from west to east. So basically, the direction of current is given in the question. Direction of current is given in the question from west to east. So the direction of magnetic field 1 meter above is. So direction of magnetic field 1 meter above is north to south, south to north, east to west, west to east. Okay. Basically, what's happening in this question? Current carrying conductor lines carries from west to east. Okay. So this is north, this is south, this is east, this is west. Okay. So there is current carrying conductor from west to east. The direction of magnetic field 1 meter above is. Direction of magnetic field 1 meter above is. Okay. The question asking you the direction of magnetic field 1 meter above. So if you use the right hand thumb rule, so the direction of magnetic field will be something like this, yes or no? And use right hand thumb rule. Use right hand thumb rule. Direction of magnetic field will be like this. So now read the options. So direction of magnetic field is north to south, south to north. This. Correct answer will be north to south. So if you see correct magnetic lines will your fingers will wrap from this to the north to south direction space. Okay, in a space, in a space, in a space. Okay, so that's why I'm saying north to south. Next question I'm saying among the following, one is incorrect in the case of a straight current carrying conductor. Okay, so a straight current carrying conductor, is current carrying conductor is straight. So if one is wrong, so we need to find out wrong. Straight current carrying conductor. So this is relation is given. Okay, B and okay relation between B and I by R. B and I by R. So you need to find out the relation between B and I by R. So what is the relation between B and I by R? What is the relation between B and I R? This is again this is third graph. And this is for graph B and I also graph is given B and I also your graph is here. Okay, so correct answer will be this is the graph between B and I. This is the graph between B and I. This is the magnetic field of the case of straight current carrying conductor. For straight current carrying conductor, what is magnetic field basically? Mu naught I by 4 by D. Mu naught I by 4 by D. Okay, 4 by D is what basically D equals to mu naught I by 4 by D is what 4 by R. So basically what B is inversely proportional to R. So if B is inversely proportional to R, so the graph will be hyperbolic. Graph will be hyperbolic. Graph will be hyperbolic. So that's why I'm going with these options. Okay. Now we are moving for next question. The next question we have is cosmic rays are said to be highly energetic photons hitting the Earth on account of magnetic field. They should get uh, deflected to north. Okay, so basically what I'm saying, you need to focus only on the charge that is protons, that is positive charge, and you need to consider the Earth magnetic field. You need to consider the Earth magnetic field and then apply the law. So they should get deflected. Deflection. Deflection will be in the direction of force. Deflection will be in the direction of force. So it will deflect towards the east. It will deflect towards the east. Okay. Relative heating the earth on account of what magnetic field. They should reflect it towards the east. We are moving for next question. Cyclotron is a device which is used to produce. Cyclotron is a device which is used to produce high magnetic field, a high electric field, high speed electrons, and high speed ions. It's very easy questions. Okay, so high speed ions. Okay, some of the students do some mistakes that they click that's high speed electrons. That is wrong. Basically, we are using this for okay, positive charge, positive ions. That is high speed ions. Okay, high speed ions. So high speed ions. Okay, cyclotron is used to produce high speed ions. Next questions we are moving with. Okay, the figure shows a uniform magnetic field directed to the left and the wire carrying a current into the face. Okay, so into the face, so the uniform. So I had drawn the figure on left. Okay, see. So this, and figure shows the magnetic field directed towards left to the left. Okay, so magnetic field is towards the left. Okay, no problem. And the wire carrying a current into the face. Okay, so a wire carrying a current into the face. This is direction of magnetic field, and direction of current is into the page. Okay, into the page. The direction of current is into the page. The magnetic force on the wire is. So you need to find out force by using U equals to I L cross B. I L cross B. So L is the basically direction of current. Okay. So see L is okay inside the page. Okay, in the page. Okay. So basically what's happening into the page. Okay. So now you need to do L cross B. So if you do L cross B, L cross B, L cross B. See L is inside the page and this is B. So use your right hand rule. Okay. Use your right hand L cross B. Do L cross B, you will get direction something like this. You will get direction somewhat like this. Yes or no? Tell it. So now we are going with options. So we see the correct answer. So correct answer will be what? See, this is the direction of okay. This is the direction of and this is the direction of yeah into the okay into this is cross not dot. So this is cross. Yes, this is cross into okay into and so this is the direction of magnetic field now. So this is towards the top of the page. So going towards the top of the page. Okay, correct. So now you should know the basic application, then only you can do such questions. Otherwise, it will be difficult for you to understand the questions. Okay. So next questions we are moving with the current carrying wire produces in the neighborhood. So yeah, question talking about if there is a current carrying a wire. So produce electric field, magnetic field, electric field only. Okay, magnetic field only. So if you know that all the concept, then only you can do this question. The correct answer is magnetic field only. Okay, magnetic field only. Next question we are going with in if a long hollow copper wire carries current, then the magnetic field produces will be. So in this question, if a long hollow copper wire carries current, okay, then the magnetic field produces will be okay inside the pipe only. Read this option outside the pipe only, neither inside nor outside, and bottom inside or outside. Okay, so outside the pipe only. Okay, because in this case, this is a hollow. This is a hollow. So hollow. So there is no. Okay, there is if you apply Ampere circuit law, so there is no current inside it. There is no current inside it. So magnetic field inside the hollow copper wire is zero. Magnetic field inside the hollow copper wire will be zero. So if you don't understand the supply circuit law, the only you can understand. Otherwise, it will be difficult for you to understand the questions, and it will be more difficult to remember the questions. That's the thing. Next question, we are going with magnetic field at a point on the line of current carrying conductor. This is very easy questions. Everyone do this question. Maximum infinity zero, infinity finite value. So correct answer is zero. Next question, we are moving with the magnetic field due to current element is independent of current fluid distance from it. Okay, magnetic field. Okay, its length and nature of the material. So correct answer is nature of materials. It does not depend on the nature of materials. Okay. Next question we are doing with the direction of magnetic produce of a linear current is given by direction. Also, we are talking about direction of magnetic field, right hand thumb rules, Fleming left hand rules, Joule's law, and Ampere's law. The correct answer is what Fleming's left hand rules. The direction of magnetic produces at a linear current is given by Fleming left hand rule. So you can use Fleming left hand rule as well. You can use Fleming left hand rule as well. Okay. So. Next question we are talking about the current I flows from an infinity long to a conductor. If R is the perpendicular distance from a point from the middle point of the conductor, then the magnetic distance B is given by. Okay. So basically, this question is for what? In this question, if R is the perpendicular distance from a point from the middle point of the conductor, By chance, a pretty long wire, long straight wire in the power station. So this is what a straight wire, and this is the straight wire. With straight wire, R is the distance here. For particular distance of point from middle point of the conductor, then from middle point is center, and obviously a conductor and a magnetic field is given there. So again, it's easy questions. If you see, if you apply the Ampere circuit law, so what will come? Okay, this will come what? If point is outside, mu not I by 2 pi r, it will come like this. Okay, mu not I by 2 pi r, if you apply Ampere circuit law. If you apply Ampere circuit law, so you have options, and this so correct answer will be first one. If you solve first one, this is the same relation. Okay, if you solve first one, this is the same relation with mu not I by 2 pi r. This is the correct answer. So you go with this option. Okay, next we are moving for next question. So two very thin metallic wires placed along X and Y axis carry equal currents as shown A, B, and C. So are lines are fortified with their axis having origin at O. The magnetic field will be zero in the line. Okay. This is very easy questions again. Two very thin metallic wires placed along X and Y. This is X and this is placed along X and Y axis equal currents as shown in figure. Okay, carry equal currents. Basically equal currents. This is current, suppose I going, there is a current I going. Okay, current as on ABMCD. Okay, so as on ABMCD lines are 45 with axis having origin at O, then magnetic field will be zero. Magnetic field will be zero. So I'm showing you the options and all. So this is the okay. See, if you see A and B, A, B and C, D in this question, if you see A, B and C, D, if you see A, B and C, D, so AB and CD is here. See, this is AB and this is CD. This angle is given 45 degree. Okay, am I right? This angle is given 45 degree. The axis having origin. This angle is 45 degree. Okay. So X and Y axis, two very thin metallic wires placed along X and Y axis carrying equal currents as one AB and CD are lines and 45 degree axis having origin. The current is in Y axis as well. X axis is dot. Okay. And this is the line, and now this magnetic field will be zero on the line. Okay, basically, the question is talking about on the line. Basically, question is talking about on the line. Magnetic field will be zero on the line. Okay, so if you see this question carefully, so magnetic current is going on y-axis as well as current is going on x-axis. Okay, current is going on y-axis and current is going on x-axis as well. Okay, this okay and this. Okay, so if you see find out magnetic field at any distance, suppose you will take this distance. So if you take this distance, the magnetic field will be what? Magnetic field at this point will be because of this distance. So yes or no? Magnetic field because of this distance. If you apply okay a direction, if you apply right hand rule, if you apply right hand rule here, magnetic field in this region, magnetic field will come what? Outwards. So outwards means you take dot. Okay, and here if you apply magnetic field, it goes inside means cross. Okay, cross. Magnetic field will cross with this side. So net at this distance, obviously magnitude will be same. So net here will be on this line. If you see somewhere, it will be zero. It will come zero like this. This is AB line. Okay, if you check CD line somewhere here, so what is happening? Suppose here we are finding out the magnetic field. So what is happening? This is magnetic lines, and suppose that you need to find out at this distance magnetic field. Okay, if you apply magnetic field here magnetic will come outwards. Means suppose this will come dot because of this wire. If you will find out magnetic field because of this wire, so if you see the direction of magnetic field here, again it will come outward. So this is not going to be zero. So you should think like this. Once you think you know, match your answers with the options, then you can do it easily. Okay. So correct answer is along AB. AB. So you can check AB this side also. See, I showed you by checking this side only that this is coming zero. You can check for this side also. You can find out the answer. Correct answer. Okay. So this question is done. Next question we are moving with. Okay. Okay. A vertical straight conductor carries a current vertically upwards. A point P lies to the east of it at a small distance. And another point Q lies to the west of the same distance. The magnetic field at P is okay. Greater than Q, so vertical straight conductor. This is easy question to read. Okay, so for this vertical straight conductor carries a current I vertically upwards. So this is vertically upwards current I is going, and a point P lies to the east of its at a small distance. There is point P. This is east. This is a small distance. R another point Q. Another point Q lies to the west at the same distance of the R magnetic field at point P is greater than Q R R. So this is easy questions. Okay. This is easy questions. Okay. So go through the options. What is correct answer? The correct answer will be greater than at Q. Okay, greater than at Q. When the point Q lies to the west at the same distance of the magnetic field at P is Basically, what's happening in this question, what's happening, a vertical split conductor carrying current I vertically across, and the point P lies to the east of it at a distance, at a small distance, and another point Q lies to the west of west at the same distance. The magnetic field at point P is. So basically, if you see, in this question, no, don't go with greater than Q. If you see this point is also at the equal distance, this point is also equal distance, so the direction will be different. I agree, but the magnitude will be same. Magnitude will be same. So we can go with second option. Okay. So this is our questions, and you can okay think on it like this. Okay, and now we are moving for next question. So for a given distance from a point, current element in the magnetic induction is maximum at an angle measured with respect to the axis of the current. Okay. So for a magnetic given distance from for a current element, the magnetic induction is maximum at an angle measured with respect to the axis of current. So this question talking about magnetic induction will be maximum. Again, it's easy questions. Correct answer is pi by 2 because magnetic induction is what? Okay, if you say phi E dot A, if you take suppose B dot A in that terms, you should like things like this. So this is what cos pi by 2 is maximum. So think like this. Okay, cos pi by 2 is maximum. Next question we are talking about, okay, the magnetic field dB due to a small current element dl at a distance r is current element. Okay, so this question is basically based on okay, this law of dB equals to mu naught by 4 pi mu naught by 4 pi I dl cross r dl cross r. If you take here r vector, then this will goes r cube. Okay, I dl cross r by r cube. IDL cross R by R cube, or you can also write with this one as mu naught by 4 by IDL of the IDL sin theta by R square. IDL sin theta by R square. So you see the options DL cross R and DL cross R, this. Okay, so correct answer will be what? Fourth one will be the correct answer. The fourth one will be the correct answer. Fourth one will be the correct answer. So next we are going for next section. The next questions we have is a state conductor current I is split up as shown in the figure. Radius of the circular loop is R. See, the radius of the circular loop is R. The magnetic induction at O is equals to. So see, in this, if you check out the magnetic field because of this, magnetic field because of this, so it will be, okay, cross. If you see magnetic field because of this, it will be cross. If you see magnetic field because of this portion, so it will be what dot. It will be what dot. Okay, so that field at this subtraction of this is I1 and this is also I1. Okay, now you can do this question easily. Equal currency is following with cross and dot. Okay, equal current is following with cross and dot. So correct answer should be zero. Correct answer should be zero. For this question, correct answer should be zero. So next question is I am moving ahead is first result of length I Hamilton given by. Okay, so this is very good question, easy question, doable questions. Okay, so everyone should do this question. So what is the correct answer? And given by, so correct answer will be what? Mu naught Ni cos theta 1 minus cos theta 2. Okay, mu naught Ni is given by. See here also, because this relation from the time also we use like this, mu naught Ni, mu naught Ni and I. Okay, so mu naught Ni n by Li. Okay, so you should also keep this relation in your brains here. N by L is the number of turns per unit length, number of turns, number of turns per unit length, number of turns per unit length. Okay. So next question are moving with it is this is questions of we have or informative field project which is the field directly into the page, mm, into the page, and the charged particle moving in the plane of a page, following a clockwise spiral of decreasing radius and so on. So basically from here, what we are doing, charge a particle from outer to inner position, outer to inner like this, okay, decreasing radius, okay, so decreasing radius, so clockwise spiral of decreasing radius, so on. So what is the explanation for this? What is the explanation for this? Basically, what's happening? See, what is the formula for radius? Radius is what mv by qb. Radius is what mv by QB. So if I will increase magnetic field, if I will increase magnetic field, automatically radius will decrease. But do you agree? Tell me, do you agree? Do you agree? Yes or no? If you think like this, charge negative is going down, and the charge negative is the charge negative is spreading up, and this. So if you apply this law, so what's happening? So charge is negative and showing dot. Okay, the charge is negative and showing dot. So. You can think like this. You can think like this. Okay, reasonable explanation. We can create another explanation as well. So also okay, we can create another explanation as well. So current is from left to right in the conduction. Okay, current is from left to right in conductor. So magnetic field is into the phase. Magnetic field is into the phase. So basically, into the phase is what? Okay, into the phase. Magnetic field is into the phase, and point S is at the higher potential then point T. So this means basically what T is at lower potential. The charge carries R. Charge carriers are. So there are also charge carriers. So current is because of what? Current is because of what? So current transfer will be positive. Current transfer will be what? Positive. So by this way we can approach this question as well. Next question we are moving where the current carrying coil is placed with the plane in the magnetic meridian of the Earth. When seen from the east side, a clockwise current is set up in the coil. East side if you see, and when the magnetic field at the center will be directed outwards. Okay, so person talking about magnetic field at the center will be directed towards what is that comes from north, south, west, east, that comes will be west. Okay, directed towards west. Okay, so next questions we are moving ahead. Next questions we are moving ahead is that okay. So if we double the radius of the coil, keeping the current to it unchanged. Okay, if we double the radius of the coil, keeping the current to it unchanged, the magnetic field on the axis are very far away points. Magnetic field is between the coil, so magnetic field on its axis are very far away points. Okay. Very easy questions, radius of the coil. So basically, if I will say what is magnetic field because of the coil, what is center? U naught I by 2R. U naught I by 2R. This is magnetic field at its center. Yes or no? So, what's happening in this question? So, okay, so what is the radius of the coil between the current same double the radius? So becomes okay. So basically, what's happening? So this is unchanged. Okay, magnetic field on its axis at the very far away from the okay point. Okay, so basically, what's happening? This is coil, current carrying coil. Okay, this is current carrying coil. Okay, so magnetic field because of this axis at this point. Okay, so basically, see this point. So magnetic field at this point will be what? Okay. Magnetic field at this point will be mu naught and I r square and I r square by 2 r square plus x square power 3 by 2. 2 r square plus x square power 3 by 2. Do you agree? Do you agree? So this is what? Okay, this is what? Okay, mu naught and I. You can also write in terms of area by multiplying pi and all. Okay, so by multiplying to pi and all. Okay. So in this relation, okay, if you put the values, you can get the answers easily. Like this, you can do this question. So answer will become 4 times. Okay. Next question, we are moving ahead. A globally wound helix made up of strip wire is mounted vertically to the lower end, just touching the base of okay, mercury. When a current flows through the battery, started the coil through the mercury. So a loosely wound helix made of strip wire is mounted vertically with the lower end just touching the disc. On the mercury, when a current from the battery started in the coil, the wire oscillates, the wire continues making contact, the wire breaks contact, when the current is crossed, and mercury will expand by hitting due to the current. So the wire will oscillate. In this question, the wire will oscillate. So oscillation will start, oscillation, the wire will start. Next question we are moving with electron charge. E moves in a circular orbit of radius r around the nucleus. The magnetic field due to orbit motion of the electrons at the site of the nucleus is okay. At the site of the nucleus is the angular velocity of the electron is this. Omega is the angular velocity. The question is talking about. Question is talking about is this about magnetic field due to orbit motion of the electron at the site of nucleus B. So because of orbit of electromagnetic field is D, so question is talking about the value of omega. So this question answer will be what? The answer will be 4 pi RD divided by mu naught E. So basically what? Mu naught E in place of mu naught E. What is mu naught E? That is E is what? In place of charge. Okay, mu naught E is in place of charge. E. Sure. Next question.